Hello. So in this lesson, we're going to be speaking about how we work with the center of mass and a few more details about it. So the first question is, how do we work using the center of mass, the notion? So the center of mass of a system is only moved by external forces. Okay, so the only forces which act on a system with a center of mass are external forces. For instance, if here we have the Earth, and here we have all sorts of bodies, okay? And we're told that this is our center of mass, okay? Now these bodies can be bouncing off each other with different forces acting all over the place, okay? Also over here, it doesn't matter. The only force that we can say is moving this system is the external force, which is due to gravity. Okay, so this is the only force which matters, which will move the system, and this is due to gravity. The forces within the system acting on one another aren't important. Another example as to why working with a center of mass can also make answering certain questions significantly easier is if we take over here, we have a girl, okay? And inside her body, she has all sorts of vessels, molecules, cells, whatever it will be. And all of these things inside the body, as you know, have forces, okay, and are affecting what's going on within the body. However, this doesn't matter to us because if we just look at the center of mass of the girl, which is around about just above the stomach, then it makes dealing with a question of someone applying a force to the girl, okay, and pushing her. So instead of doing the whole calculation on every single molecule and what's happening, we can look at some kind of body just as a point mass, and then we say if a force is applied, then the girl will move forwards. Okay, so it can really simplify answering certain questions. Another example that we can give, let's split this over here, is if we look, for instance, at a rocket launcher. Okay, so the launcher launches the rocket and it flies forward at some kind of velocity v0. Okay, now as we know, the rocket will fall, okay, it will shoot in a ballistic fashion and land, okay, on the ground like so. However, if we say that, for instance, the rocket splits over here, okay, so this is section 1 of the rocket and this is section 2. And then from the split, there's some kind of force, okay, which means that section 2 will fall over here, okay, so this is section 2. And section 1 will carry on in this direction and say it will fall over here, okay? So what we can say is if the full rocket, if it wouldn't split, it would land over here. After the split, the center of mass will still be here. Okay, the center of mass after the rocket is split into two pieces and each piece has gone its separate way, depending on the forces acting, the center of mass will still remain and fall in the exact same place that the whole full rocket head would have fallen. Okay, so this is another good trick that you can apply to certain questions. So